as shown in figure. So we have to calculate the expression for current I. Find the current I in the circuit. Find the current through the resistor R. So now, whenever you get a diagram like this, you just go for, say, the rod will rotate in such a way that it will not disturb the resistor. You must go back to the basics all. So let's give some points like a O. One problem you can understand, you can manage, similar to like motion EMF, long rails. What was the role of the long rails? They were just like a connecting wires, no? The same thing with the ring here. This is O, A, okay, this is B, and let me take this as C. And let me take this D. Let me indicate that point. It will be much easier for us. So now a rotating rod, what you should replace? The rotating rod with a cell. The rotating rod with a cell. So this is what that ring. This is what that ring. And what about the rod? There's a rod. And what we do, the rotating rod should be replaced with a cell. So can you give the polarity now? B bar into the plane velocity. So this end should be positive. So the in place of rotating rod, I'll bring a cell here. So this should be a cell of EMF. It will rotate constant angular velocity. EMF induced across the cell will be constant. And this is that resistance R. This is O, A, B, C, and D. Is asking to get expression for current I. So first, what is E equal to? E equal to B omega L square by 2. Now, why the polarity? Again, Fleming's left-hand rule. Assume B bar into the plane. Tangential velocity of any point on the rod you give it. The thumb will be pointing towards O. So therefore, the end O will be positive. The positive charge will drift towards O. Okay, how to get the overall the circuit here? This you redraw it, because redrawing is what essential for you, because I'll bring many other circuit problems. Now, where is the cell? Cell is here. You start like this. This is O and this is A. From O, what will happen? There's a resistor R. Keep that resistor R here. And from O, what will happen? It is connected to B. From resistor R connected to point B. From B to A, there's an arc. There's an arc. Arc, what will happen? ADB. So this is that arc. So BD, this is A is a common point. Then from A to B, again there's a one more arc, ACB. So bring that arc, ACB. It's O, no? So what is the role of ring? It's just like a connecting wire. Then what is the expression for current I? It will be this one. So what is I is equal to E B omega L square by 2R. So the ring, what happened? Just behaves like a connecting wire. Treat it as a connecting wire. Okay, agreed, no? Now, if the ring is having resistance per unit length lambda, tell me what you make changes. The arc ADB, it all depends upon the angle. No. The angle between the resistor, the arc length AB, what pen will determine the resistance. Suppose a given instant 90 degree, I'm showing it. Then this will have resistance, RADB. The other arc BCA will have resistance. Replace that with resistance and work out the problem. And we know as the rod rotates, what happened to length of the arc AB? That keep on increase. The resistance of this what happened will increase. The resistance of this will decrease. Then what happened to effective resistance?